First essay question asks about what the purpose is for all of the assumptions you have to make before you do a confidence interval. And so to do that, we're going to make a video in a video. This is crazy. 2 videos in a video. When we're dealing with means, we have these conditions here that we have our data from a random sample, population size at least 10 times the sample size, and that our sample size is at least 30. For proportion, the first 2 are exactly the same. Random sample, population size is at least 10 times the sample size, but then this last one is different, at least 10 successes and 10 failures. So let's go through the first one. The first one refers to it being random from an SRS. If your data is not random, when we went through this when we did our sampling, your confidence intervals are going to be garbage. If you take in bad information, then any pretend confidence you spit out, that mathematical formula that you're using, doesn't have any meaning. So you have to be random to make sure that your data actually represents the population. You have to have low undercoverage, you have to have low non-response, use a valid technique, things like that. So that's not new. We've practiced that one. We always checked for that in the past. The last 2 conditions in both cases are referring to not having a normal shaped distribution. All of these formulas that we use when we're basing it on the normal curve assume that our sampling distribution is that normal shape. And if we don't meet these conditions here, there's actually a good chance that that won't happen. With the population size being too small, you run into issues with dependent probability, and I go into that a little bit more in that video with means. But what it does is it essentially changes the shape of the curve so that it's no longer a normal curve, and all of our calculations won't work. When you're dealing with means specifically, that n is greater than or equal to 30 condition, that goes back to the central limit theorem. It's possible you could have a smaller sample size and have a normal distribution. It would depend on what the starting distribution is. But for our purposes, just to be safe, we want to say that we have a large enough sample, and it's reasonable to have a sample of at least 30. It guarantees us a normal shaped curve, essentially, as long as there's no major outliers. Down here, with the at least 10 successes and at least 10 failures, we talk about what that might look like as far as the shape of the distribution. And you can see here in this video how if you have too few failures or too few successes, basically too many people who say yes or too many people who say no in the survey data, what happens is your curve gets bunched up along the side, and it's no longer a symmetrical normal curve. Now it's a skewed curve, and we don't have ways right now, very easy ways, to do the middle 95% of a curve that looks like this, in the same way that we have our calculators with normal CDF, or there's lookup tables, things like that, to do those calculations for a perfectly normal curve. So essentially the last 2 conditions deal with the fact that our curve stops looking normal.